Hello, welcome to Life Matters. I'm your host, Brendan O'Connell. And just as a point of background, I'll just tell you a little bit about him. He was born and raised in New York City. He graduated from Yale University in 1971 with a degree in biology. He then matriculated at NYU, where he was conferred a PhD in biochemistry in 1981. He has been a professor at Baruch College at the City University of New York for 28 years, teaching biology and endocrinology, which is the study of hormones. For the last several years, Dr. Brind has been conducting research on amino acid metabolism, and it has to do with what many of us in our society are afflicted with, and that's inflammation. And what is the cause of this inflammation, and is there a way to handle it, and has research gone down the wrong path with inflammation? Well, we're going to ask Dr. Brind today what he's done in his research, how his research has crossed roads with the whole issue of inflammation, and see if he has any solutions to the problem. Well, welcome, Dr. Brind.
Thanks. Great to be back.
Dr. Brind, how can you tell us a little bit about your research? What amino acid metabolism? Most folks wouldn't know what that is. What is that?
Well, amino acids are like the Lego blocks that proteins are made of. Right, so proteins are made of these building blocks, of which there are 20 that the body uses, and 8 of them are essential. That is to say, the body can't make them from scratch. We have to eat them from protein-containing foods like meat, fish, poultry, for example. My research actually did not start in the area of inflammation in this area. What we were working on had to do with amino acid content of the diet. And a group of people that I was working with at a foundation in New York was looking into the life of rats, and found that rats, laboratory rats, if you feed them a diet which is almost deficient in one of the other amino acids, an essential amino acid called methionine, the rats live about 40% longer. And it took about 20 years before the field of aging research actually began to accept the idea that there was something called methionine restriction as a real phenomenon that could increase the lifespan of animals. But nobody could figure out what that was, why that was. And the story of methionine is interesting, because methionine is one of the 8 essential amino acids. So if you look back over at the research literature going back decades, almost all the emphasis has been on how does the body make sure that we have enough methionine, because methionine is important. It's not only for protein structure, but you also need it to make DNA and so forth. And if you don't have enough methionine, ultimately you'll die from it. So the research focused on how methionine is recycled, reused, regenerated, salvaged, all of these intricate pathways that the body has to make sure we get enough methionine, because the body's really designed to undergo periods of famine. It's not really designed to have bacon and eggs for breakfast and a tuna fish sandwich for lunch and a steak dinner. You know, the kind of 3 squares a day is really an awful lot of protein, a lot more than we need. And in fact, the muscle meats that we eat are very, very rich in methionine. So we typically eat about 10 or 20 times more methionine than we need. And contrary to the body's exercising these pathways to conserve methionine most of the time, in the hour or so or two after you eat, when your liver mainly is processing the nutrients that have been generated by the digestion of the food that we've eaten, is actually busy getting rid of methionine as fast as it can, because we have far too much. And because the body views it as toxic. It actually can generate toxic byproducts. So your body's getting rid of it. The only problem is, in order to get rid of it, the liver needs to use another amino acid called glycine. Now, glycine is the simplest of all the amino acids, and it's non-essential, which is why it's largely been ignored, which means your body can actually make it from scratch. I mean, your liver can actually make glycine from carbon dioxide, formaldehyde, and ammonia. It can make glycine. So it's a really, really, really simple molecule. Trouble is, it's also the most abundant amino acid in your body, and it's therefore very high content in the most abundant protein in your body, which is collagen. Collagen is the most abundant protein in the body. It makes the protein content of the bones, connective tissue, tendons, ligaments, eyeballs, all of that is mainly collagen. And collagen has most of the glycine. So when we eat muscle meats, meat, fish, poultry, what do we do with the collagen? We usually throw it away. So,
which is the sinew and the meat?
yes, the sinew, the stuff you can't chew, you know, you finally have to just throw it away, or you just throw the bones away, or you don't eat it. You buy fillets of chicken or fish or any of those muscle meats. You buy the muscles. We cut it off the bone. In other words, the biggest amount of processing that we do in meat, fish, poultry is cutting it off the bone and throwing the bones away. Well, of course, in the old country, our grandmothers didn't throw the bones away. They threw the whole chicken and the whole rest of the animal into the soup pot, boiled up the bones, got the collagen out of it in terms of chicken soup. And that's restorative, and that's pretty much why it is, because we're getting back some of the glycine. Why? Because it turns out that glycine is really the most important inflammatory regulator in the body. And most people are glycine deficient. Now, once I realized that glycine was important for getting rid of methionine, I started taking 8 or 10 grams a day as a supplement myself. Why? Well, simple amino acid. That's about as much as we throw away with the collagen, with the bones that we throw away. So why not take it and see what happens? Well, to my surprise, of course, nothing happened for a while until various things happened. So one day I actually had a fall. I fell off a stack of some sheetrock onto the concrete floor of a Home Depot, 4 feet onto my tailbone. Hurt a lot, but only very briefly, and that night I actually went dancing with my wife. And the next day all I had to show for it was a bruise, but no residual soreness. Then I got, I don't know if I want to say this in a Boston studio, but I got tickets to my beloved New York Yankees in their brand new stadium.
Sacrilegious.
Well, I paid for it. I paid for my crime, because there I was in my Yankees t-shirt and my shorts, sitting out there in the brand new Yankee Stadium on a bright, cloudless day in June, right around the solstice with the sun beating down, and right around the 5th inning. I started to get this warm feeling in my legs and looked down and realized that I hadn't done this to myself since I was in my 20s. I was red as a lobster, my arms, my neck, my face, my legs. So, of course, I knew I was going to pay for my sins, as I said. The next day, that night, the next day, and the next couple of days being in a lot of pain with burning and blistering and peeling and all the rest of it. The first thing I did, of course, is I got out of the sun. And then what happened is it just started to go away. And it never hurt. It never blistered. It never
and this
peeled.
is because you were on a glycine
I was taking
regimen,
8 or 10 grams a day of supplemental glycine. And so I realized what the discovery, the real fundamental discovery, which the world doesn't really know about yet, is that most inflammation, and they do know, medical science does know now that most chronic disease, heart disease, cancer, arthritis, Alzheimer's disease, diabetes, all of these chronic diseases are rooted in some kind of chronic inflammation. But the medical community does not understand why that is. And what I discovered is that that is mainly a nutritional deficiency of glycine. The real discovery is that even what medical science views as normal inflammation is not normal. Inflammation, if you ask a doctor, they will probably tell you that inflammation is a normal response to tissue injury and part of the healing process. I know for certain that that's not true. Inflammation is only your body's first response to infection. If you have a blunt injury, if you have a sunburn, if you didn't break the skin, if you didn't provide a route of infection, there should be no inflammation, because when you're not glycine deficient, there isn't any. And consequently, healing is much quicker. So this is really, now I can't say for sure that, take 8 or 10 grams of glycine a day and you're guaranteed never to get heart disease, never to get cancer, never to get all the rest of it. But theoretically, it should prevent all that, because it does prevent the inflammation.